The topics of discussion are: what are programming paradigms? A brief introduction to C++. We'll see a sample C++ program, the C++ standard libraries, how do we have precondition and postcondition for C++ functions, the namespaces in C++, the header files, the scope resolution operator and its use, the constant member functions and variables, the reference variables, the switch case statement, and how do we write a C++ menu-driven program using a switch case statement. In this topic, programming paradigms, we will discuss what is a programming paradigm, what are the various types of programming paradigms, and to which programming paradigms C++ falls into. Programming paradigm. Programming paradigms is the style of writing the code. That is, it defines how the program statements are written to perform a particular task. There are two main categories of programming paradigms. They are the imperative programming paradigm and the declarative programming paradigm. In imperative programming paradigm, the statements in a programming language define how a task is to be performed. That is, each statement gives the way by which a task is completed. That is, the set of statements in the programming language is very descriptive to perform a particular task. The second type is the declarative programming paradigm, where the statements of the program just defines what task is to be performed. So, in this type of programming language, the statements are just commands. These commands abstract how the task is performed. So, in declarative programming paradigms, the program statements specify what task to do. So, this imperative programming paradigm and the declarative programming paradigm has subtypes. In imperative programming paradigm, the subtypes are the procedural programming paradigm, the object-oriented programming paradigm, and the parallel programming paradigm. In declarative programming paradigm, the subtypes are the functional programming paradigm, the logic programming paradigm, and the query programming paradigm. Let us discuss these programming paradigms in detail. Procedural programming paradigm is a type of imperative programming paradigm. In procedural programming paradigm, the lines or the statements in the program are written as procedures. So what are procedures? Procedures are subroutines that consist of series of computational steps to be carried out. Procedures can be reused. For example, consider these statements. Here, the mul by 2 is a procedure and that is called from the main program. Here, this mul by 2 procedure multiplies each member or each element in the list LIN by 2. So, whenever we call the mul by 2 with the parameter as a list, it multiplies each element in the list by 2. Here, this mul by 2 procedure can be reused at different parts of the program using different lists to perform the task of multiplication of each element by 2. Object-oriented programming paradigm is a type of imperative programming paradigm. The basic entity in object-oriented programming is the object. The object consists of data and its related computation. Object is an instant of the class. That is, the class defines the data and its related functions. The style of C++ programming is object-oriented programming. So let us see an example using C++ programming. Here we define the class person, which has the data defined as a variable name, and its related function setName sets the value of name with the input argument. We have the function main. In main, the execution of the program starts. So in the main function, we define the object P of type person. We set the value of the variable name using the argument to the setName function, which is Bob in this example. We can access the value of the name variable in the person class using the object P with the dot operator. P.name gives the value stored in the variable name in class person. So here we see the object consists of the data and its related computation, and it is an instant of the class. Parallel programming paradigm is a type of imperative programming paradigm. In parallel programming paradigm, two or more computers jointly solve a computational problem. That is, when two or more computers are combined, it can speed up the process. The combination of computers can be done by two different ways: the horizontal scaling and the vertical scaling. In horizontal scaling, the scaling is by adding more machines in the pool of computational resources. That is, more individual machines are combined as a network to form clusters to perform a particular task. The second type is the vertical scaling, where more power is added to a single machine. That is, more cores of a CPU are added to the machine, more RAM, more memory is added to a single machine. The example of vertical scaling is the supercomputers. Functional programming paradigm is a type of declarative programming paradigm. In functional programming paradigm, we will specify what task has to be performed rather than how a task has to be performed. So, in functional programming paradigm, the computation is defined as evaluation of mathematical function. For example, consider a variable declared as ARR underscore unsort, which consists of 4 tuples, and each tuple consists of 2 values. The first value in each tuple is an alphabet, and it is written as B, A, D, and C. The second value in each tuple is a number written as 6, 10, 0, and 4. Suppose we would like to sort this array. So we will just specify sorted, and we will pass the argument ARR unsort and the key to be the second value in each tuple represented as x of 1. So the output of this is D0, C4, B6 and A10, and this is sorted based on the second value in each tuple. So how the sort is performed? The programmer or the user does not know. It is abstracted. But we can do the sorting by calling the function sorted with the unsorted array and the key by which it is sorted. So this type of programming paradigm is called as the function programming paradigm because the programming language defines the functions by which a particular task is performed. The programmer just has to call the function to perform the particular task. Logic programming paradigm is a type of declarative programming paradigm in which the computation is a set of facts and rules. In logic programming paradigm, the programming language defines the syntax of how the facts and rules has to be specified. The programmer has to use the syntax to write the rules and facts in the system he is programming. For example, consider a system where the programmer defines what type of food a person would like. The rules are defined as likes Mary fish. It means that Mary likes fish. Similarly, Mary likes wine and John likes wine. Suppose the user queries the system about the food liking of a particular person with the command likes Mary fish. The system will respond as yes. If the user asks likes John fish, the system will respond as no because there is no rule in the program that specify John likes fish. So this type of programming is called logic programming paradigm. Query programming paradigm is a type of declarative programming paradigm and it is used in databases. Here, the queries are the interfaces for manipulating and retrieving data stored in the database. So consider for example a table called as the EMP which stores the employer ID, last name, first name, hire date and the job title. Suppose we would like to get the job title of a person with last name Franklin, then we will post a query as select job underscore title from EMP where last name is equal to Franklin. The syntax for the query is defined by the programming language and the user just uses the syntax to retrieve the data he wants. And this type of programming is called as the query programming paradigm, which is a type of declarative programming paradigm. Introduction to C++. So far we have discussed the various programming paradigms, particularly the object-oriented paradigm, which is a type of imperative programming paradigm. To recall, the object-oriented programming paradigm defines classes and objects to perform a particular task. The C++ programming language follows the object-oriented programming paradigm. C++ programming language defines data and its related function as objects. Class is a prototype that defines these objects. The class represents data and function of all the objects of the same type. The data in the C++ classes are called as member variables and the functions are called as member functions. Header files are C++ library functions. The header files are included in the program using the preprocessor directive #include. IOStream provides the standard input and output services for the C++ program. A sample C++ program. The first statement of the C++ program includes the standard input-output library function IOStream. It is included in the program using the preprocessor directive #include. The IOStream is present as a header in the namespace std. The program has defined the class throttle and the main function. The class throttle has member variables and member function. In the class throttle, we have specified two access modifiers, private and public. The access modifiers define the scope of the variables and functions. The functions and variables that are declared with private access modifiers are accessed within the class only. The variables and functions that are declared with public access modifiers can be accessed outside the class. Position is a member variable of the class throttle with a private access modifier. Throttle and shutoff are member function of the throttle class with public access modifier. The function throttle has the same name as the class name and it is called the constructor, which is used for initializing the member variables. Shutoff is the member function which changes the value of the member variable position. We have the function main. The execution of the C++ program starts at function main. In function main, we create the object of the type class throttle. You can note that the creation of object is very similar to the declaration of variable in C++. When the object is created, the constructor is called automatically. Using the dot operator along with the object, we call the public member function from the main. That is, t.shutoff calls the public member function shutoff of the throttle class, since t is the object of class throttle. C++ Standard Library. C++ Standard Library provides a group of declared constants, data types, and functions supporting particular activity in the program, such as the input-output or the mathematical function. To use one of the library facility, a program places an include directive at the top of the C++ file that uses the facility. For a program to use the usual C++ input or output facility, the program should use the include directive to include the IOStream library from the standard namespace std. The syntax is #include IOStream. The IOStream provides the cout, the output statement, and the cin, the input statement. Cout is an instant or object of the OStream class in IOStream library to produce the output on the standard output device. Cin is the instance of the iStream class in IOStream library to produce input on the standard input device. More C++ libraries are mentioned in Appendix G of the required textbook. Is it necessary to write a C++ program in object-oriented style? No, it is not compulsory to write a C++ code in object-oriented style, though the C++ programming language is designed for object-oriented style programming. Given here is an example of C++ program that is written in object-oriented style as well as not in object-oriented style. The program that is written in blue color has the class sample.io and the main function. The program that is written in red color does not have any class. Both the program are C++ programs. They will compile and will be executed without any errors, though one of the program is written in object-oriented style and the other is not written in object-oriented style. What are preconditions and postconditions in a C++ program? A precondition is a statement giving the condition that is required to be true when a function is called. A postcondition is a statement describing what will be true when a function call is completed. Example, to call Celsius to Fahrenheit conversion function cell to Fahr, we have the precondition where the value of the Celsius temperature is no less than the absolute zero, that is minus 273.15. The postcondition for the function is a numerical value converted to Fahrenheit degrees. Precondition in C++ is performed using the C asset library. It is included in the C++ program using the #include directive. The program given here converts the Celsius temperature to Fahrenheit temperature. It has the function cell to Fahr and the main function. The precondition that is checked in cell to Fahr function is the Celsius temperature entered by the user is no less than absolute zero minus 273.15. The postcondition after the conversion is the Celsius temperature is converted to Fahrenheit degrees. It is a numerical value. In the function main, where the execution of the C++ program starts, the user gets the Celsius degree as input. The input Celsius degree is passed as an argument to cell to Fahr function. In the cell to Fahr function, the variable minimum Celsius is declared with the value minus 273.15. Using the asset function in the C asset library, the input Celsius degree is checked whether it is greater than or equal to the minimum Celsius. If the input Celsius degree is less than minus 273.15, the asset function throws an error during the execution of the C++ program and the execution stops here. If the Celsius degree is greater or equal to the minimum Celsius, Then the conversion proceed using this formula given in the cell to var function. From the main, we receive the converted Fahrenheit temperature and we display it in the standard output device using the cout statement. We can declare our own namespaces and headers in C++. That is, user-defined namespaces and headers. A namespace in C++ program is a declarative region that provides the scope to the identifiers. The identifiers may be variables, function, or classes. Here is an example C++ program that has two namespaces, ns1 and ns2. The ns1 namespace has the function value which returns 5. The ns2 namespace has the variable x which has a value 100 and the function value which returns the doubled value of the variable x. The functions and the variables in these namespaces can be accessed from the main function using the scope resolution operator. The scope resolution operator is represented by 2 colon. The value function in ns1 namespace is called from the main function as ns1 scope resolution operator value. The value function in the ns2 namespace is accessed as ns2 scope resolution operator value. Similar to the function accessed, the variables can also be accessed in the namespace. That is, the x variable in ns2 namespace is accessed as ns2 scope resolution operator x. The user-defined C++ header file has the extension .h. A C++ header file contains variables, function, and class declaration that can be used across programs. It is used in the C++ program using the preprocessor directive #include. Let us see an example of a header file used in the C++ program. To write a user-defined header file in C++, we write two files. The first file, which is the header file, is a .h file. The second file, which is the implementation of the header file, is a .cpp file. It is a practice that in the header file, we only declare the variables and the function. In the header file given here, my add.h consists of the myAdd class defined within the namespace add. The myAdd class consists of variables ab and function int add and the constructor myAdd. The implementation file of the header file has the extension .cpp and in our example it is add.cpp. The implementation file must include the user-defined header file, which is myAdd.h from the user-defined namespace add. The definition of the constructor and the function is given in the implementation file. the function int add adds the variable a and b. The main program, which uses the header file, has to include the header file using the include directive. And in the main program, we have to create an object of the class declared in the header file. Here we have declared it as my_add ma within braces 2, 3. When the object ma is created, it calls the constructor of my_add class in the header file and initializes the variables a and b. The int add function in the header file is called using the dot operator along with the object ma. The result of the int add function is stored in the variable sum, and it is displayed in the standard output device using the cout object. I would like you to practice the user-defined header file in your system so you can be more familiar with the creation of user-defined header files. Scope resolution operator. We have discussed that the scope resolution operator can be used to access the variables and function in the namespaces. It has one other use too. Scope resolution operator. The scope resolution operator is used to define member function outside the class definition. The syntax for defining member function outside the class definition using the scope resolution operator is given as return type, class name, scope resolution operator, member function name, and its argument list within the parenthesis. In the example given here, the class sample_io has member variables name and age and member function read and write. The definition of the function read and write are outside the definition of the class sample_io. The read function is defined as the return type of the read function is void, followed by the class name sample_io, scope resolution operator, and the read function. Similarly, the write function is defined as void sample_io, scope resolution operator, write. In the main function, the object SIO is created for the class sample_io. The read and write function are called using the dot operator along with the object. What are constant member variables and member functions? The value of the constant variable does not change throughout the class. The constant function examines the status of the object or the variable, but changing the value of the object or the variable is forbidden. Constant member variables and functions are declared using the keyword const. The example throttle class has a constant member function is_on. The syntax for defining a constant member function is as return value, the function name, the list of argument within parentheses followed by const keyword. From the main function, we call the isOn member function using the throttle object t. The isOn member function just checks the member variable value POS on is greater than 0 and returns the Boolean value of true or false. Any constant function can only check the status of the variable. It cannot change the value of the variable. What is a reference variable? A reference variable is a type of C++ variable that acts as an alias to another variable or object. For example, consider the variable x declared as int x. If we want to declare a reference variable for the variable x, we declare it as int ampersand the variable name ref underscore x equal to x. This statement creates a reference variable ref underscore x for the variable x. Suppose you change the value of the reference variable ref underscore x as 60. Then the value of the variable x also changes to 60, which can be verified using the cout statement. Reference parameter. If a C++ function receives a reference variable as an argument, it can modify the value of the variable in the calling function. So, to receive a reference variable, the C++ function has to use the ampersand sign in the argument list of the variable. Consider, for example, the swap function which interchange the values of variable first and second, which are the reference arguments of the function swap. When swap is called from the main function with the values a and b, it is received as reference variable first and second. The swapping of variable is done in the swap function and it is reflected in the calling main function, and it can be verified using the output statement. What is a switch case statement in C++? A switch case statement is used when there are multiple conditions to be tested. It is like a nested if, but the condition is based on the value of a single variable. The syntax for the switch case statement is given as keyword switch, within parentheses the variable or an integer expression. And we have the case statement followed by the number, which will be the possible value of the variable in the switch statement. When the constant values in the case statement does not match the variable in the switch statement, the code in the default section of the switch statement is executed. Every case statement should have a break at the end for the C++ code to exit from the switch statement. Here is an example of C++ switch case statement. In the function main, the variable I is assigned a value of 2. I is a variable used in the switch statement by which the branching of the execution goes to the set of case statements. In this example, the value of I is 2, hence the switch branches to the case 2 and the letters case 2 is displayed in the output device. Suppose we set the value of I as 3. Then case 3 will be displayed. Suppose we have the I value as 8. 8 does not match any of the case statement values. Hence, the default statement will be executed and the output will be default. When do we use a switch case statement? C++ menu-driven program uses switch case statement. A calculator is an example of C++ menu-driven program. A calculator is an example of C++ menu-driven program. The calculator does addition, subtraction, multiplication, and division based on the choice given by the user. For a menu-driven program, we have a while statement with a condition value set as 1. That is, because of the condition, the while loop never stops execution. To stop the execution of the while loop, inside the while loop statement, we specify a particular variable called exit_success at the case 5 statement, which is an option for exit from the menu. The exit_success variable is declared in the library cstdlib. It exits from the program. Coming back to the menu of the calculator, we enter 1 for addition, 2 for subtraction, 3 for multiplication, and 4 for division. When the user enters a choice, the user is asked to enter the two numbers on which the addition, subtraction, multiplication, or division has to be performed. The switch is based on the choice entered by the user. The case 1 performs addition of two numbers. The case 2 performs the difference between the two numbers. Case 3 performs the product of two numbers. Case 4 performs the division of both the numbers. Because of the while statement, the menu is repeated again until the user enters the value 5. Suppose the user does not enter value from 1 to 5, then the statements in the default is executed and again the menu is displayed to the user. This is an excellent example of a C++ menu-driven program. In this presentation, we have discussed the various programming paradigms. In particular, the programming paradigm of C++, the object-oriented programming paradigm. We have seen a sample object-oriented C++ program. We have discussed the standard library of C++, how precondition and postcondition are checked in C++, the user-defined namespaces and header file declaration in C++, how the scope resolution operator is used in C++, how we define and use the member variables and member function as constants and reference variables. And finally, we have discussed a menu-driven program using the C++ switch case statement. Thank you.